Hello, everybody. My name is Andrew Yee, along with Eric Dirks, Frial Mahmood, Fernando Ortiz, and Sam Pergano, and we are No Trivial Matter. And this is our target increment demo. So, for today's agenda, we'll be going over technologies, our architecture, as well as our database overview and some of our testing, such as our Sonar Cube scan and unit testing, as well as our full demo of our application end to end. So I'm going to hand it off to Eric to go over our technologies.
As you'll see in the following slide, we chose to split our application into 3 layers: a presentation layer, an application layer, and a data layer. We chose to write the application layer in Angular 8. Angular is a popular JavaScript-based open-source front-end web framework mainly maintained by Google. It has an MVC-based architecture which supports two-way data binding. For testing, we're using Protractor, an end-to-end Angular test framework. To run those tests, we're using Karma. We chose to write the application layer in Python, a popular high-level programming language that I'm sure most of you are familiar with. The application layer is built upon the Flask framework. Flask is a simple but extensible micro framework written in Python. By using Flask, our team was able to get off the ground quickly and start building instead of configuring. For testing, we're using Unit Test, a simple Python testing framework. The data layer is also written in Python using the Flask framework. Since this layer is a REST API, we are using Flask RESTful, an extension for Flask that adds support for quickly building REST APIs. The data layer interacts with our MongoDB database. MongoDB is a cross-platform, document-oriented database program. Document-based databases are often described as NoSQL databases. While these databases don't use schemas like typical relational databases such as MySQL or SQL Server, MongoDB supports optional schemas with JSON document-oriented database. We'll now cover the architecture of our Trivial Pursuit application. As mentioned before, our architecture is split into 3 layers: a presentation, application, and data layer. Please refer to the legend in the top right of the screen as the layers are color-coded in the diagram. The presentation layer consists of a web application, which the users interact with via a web browser. When users take actions in the game, they are registered in the presentation layer, which outputs any necessary information back to the user. When a given action requires game logic, such as moving a token, or game information, such as a question, the web application will send a request to the application layer to handle the request. The application layer handles all the game logic. For example, this layer manages the players, maintains the state of the game, moves player tokens, awards wedges, and assists in determining possible moves as the players navigate the game board. When the game requires information such as a question for a given trivia square, the application layer contacts the data layer to retrieve information from the database. The data layer handles all requests for database information. Stored in the database are all Trivial Pursuit questions and categories. As seen in the diagram, all requests take place over the HTTP protocol, with the exception of requests between the data layer and the database, which are handled via the PyMongo Python library. We'll now provide a brief overview of MongoDB and the structure of our database. On the left is our category collection. It was a simple JSON document with an ID and a name. The ID is used as a foreign key for the question collection, and the name represents each category name in Trivial Pursuit. On the right is our question collection. Each document has a reference to a category ID of the category it belongs in. It also has a question, an array of possible answers, and the correct answer. We'll now move on to a demo of the application.
The database that was used in support of creating or housing the database of categories and questions is Mongo Database. Compass is their client software for interfacing with the database. We have the 4 categories with the immutable object IDs, current color choice and current name choice for that object representing the category. Next, we have the questions that are currently in the database with their unique IDs, the matching category ID, correct answer, potential answers as an array, and the questions. Those CSVs can be used to upload data into Mongo. When uploading arrays, it's preferred to use JSON to ensure formatting is correct. So the steps for uploading the database files is first to identify the column headers, which we have done, and then fill in the category, question, potential answers, and correct answer. This CSV file can be converted to JSON with a custom written script we wrote in Python. This Python script will convert to our categories and create the JSON entries. As you can see, there's no JSON file here. We will now launch the converter to convert and create JSON from the CSV. Do this by using Python, choosing the question list. First, we'll close out the question list so that it can access it. All 100 entries were created successfully. If there was an error, it would have told us. Now you can see the question JSON file is here, and all of them have been converted from CSV to JSON. If we want to replace these, to add to the database or replace these files, click Add Data, Import File. You can browse to that question list and then import. This was a helper Python script to create the database. None of this is required to augment, change, or add questions manually to the game. There is a user interface that will be shown in the presentation layer, the UI, for the users to add, remove, and modify questions. This work was done in support of creating the initial question set.
We'll be going over the Angular application, which will demonstrate the end-to-end application flow all the way from our user interface all the way to our logic layer, which then communicates with the data layer. So as you can see, we have 3 terminals running, which demonstrates that we have our 3 layers interacting with each other. We have the Angular application here, the logic layer here, which then communicates with the data layer, which will then send any data back through all these 3 layers. So as you can see, we already have the Angular application up and running. So then we'll go and navigate to our Trivial Pursuit application, which is running on our local machine at localhost port 4200. And this will basically launch our initial landing page, which basically has 2 options that the user can prompt, which is either play game or configure game. So now we're going to demonstrate our configure game feature. So we'll click on this configure game button, which will then navigate to our configuration mode. So basically, this feature will allow any administration user, such as a teacher or any mentor that intends to distribute this game, to be able to edit questions, modify existing questions, as well as add any new questions they would want to add to the game. So then we'll demonstrate all three of those use cases. So as you can see in this question editor here, it has all of the different category names. So it breaks down all the questions within these 4 categories. It has places, people, events, and then the Independence Day holiday. So anything, you can edit any question, add any question, and delete any question you want from any category here. It's all displayed in this configuration module. So here, let's say that you want to edit this question right here. Say that you don't like the spelling of New York. You want to misspell New York. So New York. So let's do that, and then we just have to basically submit any. You can basically edit any questions that you want at once, and then you would submit the Save Changes button, and then it will confirm that. As you can see, it makes a post request to the logic layer as well as the data layer. As you can see, it edits the question, and then we can go back to the configure game. And as you can see, the data is persisted. New York is misspelled, so I guess we'll go back and edit that accordingly. And then you can also delete any question that you want. So basically, let's say that you want to delete this question right here. So where is Thomas Jefferson from? Or Thomas Jefferson, basically. So let's delete this question right here. Save the changes. And then save successfully. So if you go to configure game, you go all the way down and you scroll. So let's look for Thomas Jefferson. And you can see that Thomas Jefferson question doesn't exist here. So then let's re-add the Thomas Jefferson question back. So where is Thomas Jefferson from? Where was Thomas Jefferson from? I have the questions right here. So possible answer, Maryland, Jersey, and Delaware. So then the correct answer is Virginia. And as you can see, our add question dialog also requires that the correct answer must correspond to one of the possible answers. So then this will basically be data persistent in terms of a user can't enter any data inconsistencies to break our game. So basically, the correct answer has to correspond to one of the possible answers. So then we'll save that. You can see it's entered right here, and then we'll save the changes. And then we have a pop-up that says "Save selectively, successfully." Go down here, and then as you can see, our question is successfully added into the database, into the game. And you can do that for any question, any modification, or any deletion, and it'll persist for it. So it's a very easy, user-friendly way to see all of the possible questions within our game database, and you can modify, you can add, and you can delete to your freedom. Another feature I would like to touch upon is the ability to change the category colors and the colors that the players each can have. So as you can see, we're still in the configuration mode page, and then we're in this question editor panel. And if you click on the drop down, you can see here on the top that each of the categories has its own category color, and these will also correspond to the colors that each of the 4 players can choose. So you can see that the categories are red, white, blue, and green for the defaults. So if you want to change the category colors, we can change all of them at once, or 1 or 2, has however many as you want. So let's say that, let's make a change for this one to chocolate. And then for this category, let's make a change for red. In events, you can make a change to yellow-green. For the last category, let's say that we want this one to be blue. So all you have to do is click the Save Changes button, and you can submit as many changes as you want. It has however many colors you want, and you can also add questions, delete questions as well. Just need to hit the Save Changes button, and it'll send all the changes over to the logic layer and the data layer. So it'll say that it's saved successfully if there's a successful API response from the layers, and you can go back to configure game. You can see that the categories have changed. The category colors have changed. So each one, you see chocolate, red, yellow, green, and blue. So you can make question edits, question modifications, question deletions, and you can also change the category colors as well. So now we're going to move on and go ahead and demonstrate our actual game. So I'll go ahead and go to play game, which will then navigate to our game configuration page. So this page basically allows the user to enter in your player information, the username, and then the players can choose their color, and then you can also determine how many players are in the game. So as you can see, this prompts the user to enter in at least 2 players. So we're going to go ahead and do that. And then we choose your color. So enter in the first player. It gets rid of the color as soon as it's selected. So this will eliminate the possibility of 2 users having the same color, which could pose as a problem for our game logic. So we'll go ahead and keep entering the second player, choose the color. As you can see, as soon as we enter in 2 players, we can move on to playing the game by going to determining the player order. But we'll go ahead and finish off by entering 2 more players so we can have a full game. So as you can see, we can't enter in any more than 4 players. The prompt basically goes away, and we have to go to determine play order. So then we'll go ahead and do that, and we're navigated to the player order page right here, which displays the 4 players, their corresponding colors, and then gives them an option to roll the dice to determine their player order. So we'll go ahead and do that. So each player will roll the die, and then the application will interact with the roll die API and then return the value and display it as such. So we'll go ahead and roll the die for all of these guys, and then we'll start the game. As you can see, there's a 3-way tie, but I guess the tiebreaker would go towards whoever rolled the die first. As you can see, we have our game board with the determined player order, and we have Fernando going first. So going into more depth about our game board, as you can see on the left side, we have our graphical game board that we made with a bunch of images and components. As you can see, we have the board set up just like how it would in Trivial Pursuit, where you have the headquarters square in the middle of each sides, and then 2 roll again squares on each of the sides. And then as you can see, all the players start in the center of the hub. And then on the right side here, we have the player list component, or player card component, where we show the player name and their color, and then the amount of wedges they've collected so far in the game. So you can see this is the start of the game, so none of the players have any wedges collected. And then down here, we show the round, and then the current move that the player and the current player that is making their move, and then the current action that they can take right now. And down here we have the game categories shown down here, as you can see. So we'll go ahead. As you can see, the first player right now is Fernando. So we'll go ahead and roll a die for him, and this will interact with the roll die API again, and then return a random die value. So as you can see, it'll go ahead and move on to prompt him to choose a direction to move to. As you can see, he can move 4 squares now based on the die value that he rolled. So we'll go ahead and say that he's going to move down. Submit that. You can see his square moves all the way down to a headquarters square. And then he'll pick a card, and then the question will be, what 2 groups did the declaration not give equal rights? So we'll go ahead and submit the answer here. And then once you answer it, it'll show this snack bar angular material pop up saying that you have a correct answer. And as you can see, we're able to collect the category wedge of Independence Day holiday, and then it shows here on the player card component as well as the player token that we have here. So go ahead and keep going for Fernando since he got the question right. Go ahead and roll the die and say that we're going to go right. And then it says, according to the declaration, what causes a government to be just? So to show this capability, I'm going to go ahead and answer this incorrectly. So, as you can see, it prompts the incorrect answer pop up, and to move on to the next player, which is Faryal. So skipping ahead here, as you can see, we're in round 2 now, and back to Fernando. As you can see, he has his Independence Day holiday wedge, and Eric was able to collect an Independence Day holiday wedge in the first round. So now we're back in round 2, and we're back here with Fernando, and he's ready to roll his die. So we'll go ahead and roll die, and then we'll go ahead and move left. So now we have 2 moves here, so we're going to move over to the left. As you can see, Fernando is navigated to the roll again square. So then he's prompted again to roll the die. So we'll go ahead and roll die, and then choose a square to move. And so, of course, we want to continue moving, or you can actually move back to the headquarters square, and we'll go ahead and do that. Collect his wedge. So Fernando will try and collect his wedge. So the question is, the people of American colonies at the time of the Declaration of Independence was written were excited mainly about this part of the document. So go ahead and answer this, that thought all men are created equal. Seems like the correct answer. Submit it, and indeed it was an incorrect answer. So it'll go ahead and move to Faryal's turn again. So fast forwarding a little bit, you can see that Faryal and Eric have collected some wedges, so they're catching up to Fernando a little bit. So now it's Fernando's turn again, so he'll roll the die, and of course he probably would want to go down to the category square, so he can set his category. So you go down, and you hit the category square in the center of the hub, and then as you can see, it will prompt you to select a category. So he's probably going to want to select a category where he doesn't have a wedge. So let's say that he wants to select places. Submit category, and then you get that question. So the question is, during which war did the U.S. hide the Declaration of Independence? So probably going to just go with World War II. Correct answer. So then you can roll the die again, and choose up. So where was Thomas Jefferson from? then question is probably Virginia. Correct answer, and there you go. Now he has his third wedge. So all he needs is one more wedge in order to get his winning condition. So to fast forward, for the sake of time, we're going to demonstrate our winning condition. So as you can see, it's Fernando's turn, and he has collected all 4 of his category squares, and now he's in the center hub, ready to answer his last question to try and win the game. So he's going to pick his category. So we're going to pick places. And the question is, what are unalienable rights? And we can take a good guess for that. We'll say that they're rights that governments cannot take away. Try and answer that. So submit the answer, and it'll navigate to our end of game page, which demonstrates the winning players as well as the players and the wedges that they end up with. So that was our full target increment demo of our end-to-end application, all the way from the Angular UI to our Python data layer, Python logic layer, and MongoDB data layer. So now I'm going to hand it off to Sam, who's going to talk about our SonarQube scan and analysis, as well as our testing procedures and testing coverage.
This is Visual Studio Code, and we're using the built-in Python, built-into Python unit testing to unit test the code. Unit testing is one type of testing you can do. It tests units in the code. I have 3 of the classes open for this demonstration. You have the token, the game board, and the game state. Each one of these classes have a number of functions inside of them. You have the constructor, some calling functions that support various classes throughout the game design. And we'll use, again, the built-in Python unit tests framework to test these classes. Similarly, you have game board, where you have the creation and various functions. And lastly, game state. So looking at the test classes, they're written with key lead of test underscore, and they will flex each one of the functions we saw on the previous tabs. So for instance, test category wedge, testing if it has none. So here we feed in an empty token with no wedges, and we assert that it should come back false, that they have a category wedge, because they should not. Similarly, we can stick a single wedge in and assert that it should come back true, since there is at least one wedge. And this follows this methodology through all of the unit tests, all the way up to all of the wedges. Embedded in these, we're also testing adding wedge, which is another function. This is the same for game boards, where we're setting up the game board and checking the possible move functions, what your current square is, moving your token up, down, left, right, and lastly, game state. Similarly, setting up the characters that will be passing through the blueprints into the game state, testing the play orders, whether or not die rolling is successful and failing, the various functions in game state. To the left, we can open up or expand these tests. So game board test, here are the various tests that were ran, game state, and token. We can run all these tests again. In the background, we can see that the logic layer is up and running. the data layer is up and running, since they are required to do some of these queries, even though they're unit tests. So we will run all of the tests. To the left, you can see they're all running. Here's the output. They're all saying okay so far, and they all successfully concluded. So this is, again, one type of testing you can use to ensure your lower level functions are working properly to help diagnose problems and bugs in the software code base before you integrate. Following this, you can do integration testing and then system level testing. Continuous code inspection is very important when developing software. It helps reduce bugs that develop over time and may cost more money or time to fix later. No Trivial Matter team chose a static code analysis made by SonarQube. This is in addition to the tools that are embedded in the IDEs that were used to program the software. SonarQube boasts code reliability, application security, and reduction of technical debt. It tracks all these parameters, but the version of SonarQube that we used was the community edition, so rules and feature sets were reduced. Once the SonarQube server is started up, it can be ran on a code base, and SonarQube supports multiple languages, including but not limited to C#, Python, JavaScript, Java, etc. Once the server is booted up, you can direct it to the location that your code resides at and start the analysis. As you can see, this is the summary view of the project. Is calling out 38 bugs, 1 vulnerability, 8 hotspots, and 50 code smells. As with any static code analysis software, it can only feed you information based on the rule sets that are coded in the logic. Some of these codes, or bugs and vulnerabilities, as you'll see, are not truly applicable to our project. Clicking on the Issues tab, you can pull up various bugs, vulnerabilities, and code smells. Code smells are things that may or may not be typical practice. For instance, a code smell here is removing commented out code. If you click on it, it will bring you to the section of the code that is warning you about. In this instance, it was a visual representation of the minimal increment game board that was left as a remnant while developing the presentation layer. You can also click on why is this an issue to see why this static code analysis software is bringing up as a potential issue. So as you can see, programmers should not comment out code as it bloats the program and reduces readability. So unused code should be deleted, since you can retrieve code snippets from your code repository. Some of the more robust catches that it can call out is when it notices that you are not using variables or information in your code, but they're coded in your software. This can lead to potential problems in the future. Again, these are smelly code, but not necessarily vulnerabilities or bugs. You can also click on the bug section to look up what it has flagged as bugs. In this instance, in the presentation layer, an ID or scope attribute was not added. This leads to for hearing impaired problems if you desire to implement that later. So for this instance again, we can update these to have the ID tags, but from our requirements, these are not truly bugs that we need to worry about. Another thing I can highlight are security hotspots. So for instance, in the connector to the Mongo database, we have hard-coded passwords. No, this is not really the password. I modified this for the purposes of this video, but it identified it as a potential authentication issue since your password is stored clear text in the code. Other things it may bring up is the fact that we're calling in a call to a Rolled-I API using HTTP, not secure. So this is a potential issue if you're worried about your privacy. So if you click on "Are you at risk?" you can see that you would be concerned if you're worried about the confidentiality and integrity of the data. Since we're getting a value between 1 and 4, it's not a pressing issue to fix and find a secure Rolled-I API. So it gives you recommendations on how you may be able to fix that, whether or not it's SSH or some other secure protocol. Another screen that it comes up is the lines of codes and metrics on each one of those different folders that are broken out in the structure. CLI layer was part of the skeletal increment. So this code is in the repo, but it's not currently being used. This database to JSON code, although it has some code smells and a security hotspot, its only purpose is to convert CSV files into JSON, which is only required to initially set up the database of questions. It is not required at any time fulfilling any of the program requirements. So the three major folders here are the data layer, logic layer, and presentation layer, which breaks out the lines of code for each, potential vulnerabilities, code smells, and security hotspots. You can use this software again to refine the quality of your code and put rule sets in to make sure the code is following a cohesive format. And that summarizes the use of SonarQube, a static code analyzer, in support of the Trivial Pursuit software.
So that will conclude No Trivial Matters Target Increment demo. Thank you everybody for joining in and watching, and we hope you learned something, and we wish everybody the best.